3 higher degrees in technology. Okay, great. But that was back in the 80s. All right, so what we're going to do is talk about my perspective on what we need to do to create data-driven managers, both in the private sector and in the public sector. I'm going to share with you some of my experiences running workshops on open data, which is my area of specialty, and then some recommendations from what we've learned and how it relates to training. So I think the real reason we're all here is that we're concerned about, will history repeat itself? Are we back in the days of Y2K, ERP implementations, e-government in my world, where we found out that we're really in trouble if the technology people are there without managers. Jeannie Ross's famous paper in 2002, 6 or 10 things that that IT managers should not, the difference between what managers should do and what IT should do is that one paper. And one of the key things we're thinking about is, what are we going to do if we have strategy without data, right? That doesn't make any sense. On the other hand, we can't really have technology without any strategy. We see where that leads. Having management without the right authority also creates really strange dynamics if you have all the authority in the hands of the IT people. And fundamentally, we don't want to get into a situation where we just have a lot of IT activity without actual productivity. The way I'm framing this is that I see managers as the ultimate data consumer. By that, I mean that they have to be able to request data analytics products and understand what it is that they're requesting. At the same time, they need to interact with data products that are produced and given to them. So it can't just be sitting down. I remember back training executives and trying to explain where the enter button was, right? Like, they need to do more than that. They have to actually interact with it. And finally, they are going to be the ones who are supervising data scientists. What does that mean? Do they understand what they do? So when we talk about training managers, we have to think about people who have a wide range of skills, and this is not necessarily how to use a Hadoop cluster. So what do we need to do to create these data-driven managers? As somebody who is a computer scientist, and fundamentally a lot of us in this room are, it is a question of how do we train non-STEM users. This is an issue that the National Science Foundation is very interested in. And from what I do, I always try to think about what can we do for big data with everyday knowledge. In other words, it's not something where you have to be a specialist in some obscure field, but with something that's relative that everyone would know. A lot of what I do is about privacy and big data policy, so my personal thing was that I did not want to do anything that involved private identifying information, PII. And so we needed something that was complicated, complex but not complicated, and domain neutral, so it could be open to as many people as possible. And I fall into thinking about open data. There are lots of different definitions out there about what that means, but essentially, you're talking about data that can be shared. It has few, if no, licensing restrictions. Open can also mean that they're open technical standards, or they use formats like XML. And I was interested specifically in open government data. Open government data is unique. It is documented. There's little data out there that are documented. It's also been mandated across time, so you have incredible longitudinal sets. For instance, the UK government is scanning all of the talks that were on the floor. It's called we call it the congressional record. In the UK, it's a Hansard, but it's basically everything that's said on the floor. They're going back to the 1600s. Like, that's serious long-term data, and that is well documented. So these are interesting new data sets that are available, and I seem to think that that might be interesting for some research, and so did the National Science Foundation. In collaboration with John Wilkinson, who's at the University of Washington, we came together and put together this proposal that we've been working on for the last 3 years. John is a political scientist, I'm a computer scientist, and we decided to frame a project that would be using open government data in order to educate the next level of researchers and academics in big data. So we were looking for innovative academic research and where we would really combine these two skill sets. This is a little bit of information about the grant. We call it Informatics for political informatics, and this is how we were funded. There's a website, polyinformatics.org, that has all of the stuff about the project as well as our collaborators, and we have a number of people on our committee that are helping us. And the way we started was in 2012, is that we came up with a series of data challenges, and those data challenges led to workshops and training, and those are some of the experiences that I'll talk about today. Okay, so we had two major data challenges, and by that, this is a computer science term where you make a lot of data available. I think I was the data engineer for that. And we then put it out and offered at different academic conferences for people to do stuff with it, see what you can do, and then we judged the best ones. We were interested in two things. One was the financial crisis, and so we pulled a whole lot of open government data about the financial crisis. And then just recently in Seattle, we kicked off another one that was on climate change. One thing that people don't often think about with government data are that they are really the backbone of how this industry started. If you think about zip codes and marketing data, zip codes were an initiative by President Kennedy to improve rural delivery of mail, and suddenly there was going to be a number for every location in America. And now we have this system where it's so much marketing is based on what zip codes are. So if it weren't for some government agency coming up with some standard way to look at a category, a lot of what we call analytics wouldn't exist. I think zip code is just one example. So we're trying to figure out what's the new thing going to be like that, for that. So we did this in collaboration. The Internet Archive gave us a data set that's widely available. I'm not the only grant who's using it, in case anyone's interested. It's all of the .gov from the Internet Archive. I think it's just about a petabyte of data that's up on a cloud server, which is an interesting data set. We had one challenge at the American Political Science Association, IRE, or the investigative reporting editors. One of our steering committee members is part of the New York Times data team, and we wanted to get out to data journalists. And we also had a very successful competition with the Association for Computational Linguists. So what we put out there, the other thing, caveat I have to say is that most of you are working heavily on quantitative data packages, and when you work with government information, a lot of it, we talk about text as data. In fact, there's a conference called Text as Data. And so we're trying to work through different sets of documents and transcripts and seeing what we can find in terms of patterns, which is of particular interest to political scientists. So we had the Federal Open Market Committee scripts, that's FOMC, and we had all the transcripts. These are the people who set monetary policy for the US, and we were looking through all of their transcripts before the financial crisis to see different patterns. And interrelated documents, we were looking at the US Code and other administrative documents. And as we started to have these conversations between the technologist and the social scientist, we realized that there were these really interesting gaps in how people understood things. So just, for instance, the geospatial data, it was originally is a zip code, and somebody wants to build it up into a county level or state level data, and then there started to be questions about how it was formed and then how you use it. And the computer scientists might have a very different perspective than the social scientists. I remember one conversation about this is somebody came up with a predictive model for when a vote was going to happen in the US Congress. And the word that was the most predictive was the word suspension. And they were like, well, what does the word suspension mean? Well, the political scientist was like, well, that means suspension of the rules. And that means that the vote's just going to the floor without any argument. And so what looked like an obvious thing to the computer scientist really needed a layer of interpretation in order to make it work. So as we went from these data challenges of working with people absolutely on the cutting edge of this technology, we decided we needed to run our own workshops to figure out how we were going to do this transfer to social scientists on the innovative edge, but who didn't necessarily have the skill sets. So our focus was going to be on interpretation. There were two aspects of this that we worked on. One was context, and the other was method. And let me just review how we situated this.
Just a few minutes left, Anne.
Okay. So for context is just asking that basic question, what can we answer? What do we have? And this is the very idealistic kind of conversation. You know, we had everybody in the room dreaming up scenarios of what it was that we thought we could ask about government and how it works, and really focusing on subject matter expertise. The second level of questioning was the realistic moment where we're like, okay, what can we really do today? How good is LDA? Like what are topic models? What's cutting edge in topic models? What is it that we know for sure? What is it that's questionable in the computer science literature? And therefore, what is it can a social scientist really build a model on? And those were really fascinating conversations. And then also, what skills does it take to really get there? So my recommendations from this experience, a couple of things. The workshop outcomes, and this is what we were trying to do, is trying to build inclusive conversations so both the technologists and the people who did not have those skills could both be included in the conversations to find common ground, and building knowledge sharing so everyone's sharing their own critical thinking together. Our challenges for doing big data training are a lot of what we've already heard and talked about today. How do you get people to think at scale? So instead of just picking out 30 random choices, you know, it's like you can have everything. I was trying to explain this to political science. I'm like, you could have every word they said, and really trying to emphasize how does that make you think differently when you have that. And of course, like I said before, thinking across time, how long is it that we could go? And also thinking like a network, thinking that this is connected to that. That is a type of skill that we don't usually teach, and that's a new way of seeing data and how they're connected. I think it's also really important that we talk about the limitations of technology today and say what it is that we really can find. And in that way, we can start really working with what's real as opposed to just what these fantasies are. And one thing that's very real is that data are rarely very clean and precise. And we need to sort of expose that fact in our teaching. Chris Borgman has written a great book on big data that just came out this year, and one section she has is thinking about winner data, right? Is it an interpretation of Shakespeare from 1705 or from 1905? Because in humanities, things go across time. But I'd like to add a couple of other questions to that. Who are the data? Who are the people who produce it? How are data, how are the data produced? What do we know about the implementation? That explains something about the quality. Why are data? Why did somebody decide to set up this data set and go through all the trouble of storing it? And then finally, what are data? In conclusion, I just wanted to say that I feel that when we move towards teaching data science, we really do need to combine both the art and the science. And by art, I mean that observations are not always a fact. They are simply an observation, thinking like natural and physical sciences in that way. And that categories need to be taken in context. They are not absolute truth. On the other hand, we do have a lot of science, we do have a lot of certainty that needs to be emphasized, and that algorithms are consistent. We know what they do, we know that they're repeatable, and in that way we need to show what that is. But when we teach, we need to have both these two things, the art and the science. When I was, there was an NSF conference on the social implications of big data a few years ago that I was at, and Paul Ohm, who was at the University of Colorado, put it brilliantly. He's like, we don't need to just train data scientists, we also need to train data humanists. And I think that's what a lot of the work is that's facing us in the future. Thank you.
Just time for one question, if there is one. Well, thank you, Anne. That's really interesting, and got some synergy with some of the things you've been saying, so thank you very much.